a good day to Dr. Akmal. I will present the answer for question 1. Question 1. A metal bar with an inner shell at 25 degrees Celsius is immersed in a container of boiling water. It was observed that the temperature of the metal bar increased 3 degrees Celsius in 1 minute. Determine the time required for the metal bar to reach 85 degrees Celsius. From the question is stated temperature and time, so we will use Newton's law of cooling. What is Newton's law of cooling? Newton's law of cooling states that the rate of which a body cools is proportional to the difference between the temperature of the body and that of the medium. Inputting mathematically, the changing temperature with respect to the time is directly proportional to the difference temperature of the body minus temperature of the medium. So we are going to put this into an equation. So we will be having a proportional constant K. So we have the change in temperature with respect to the time is equal to the proportional constant K multiplied by the difference of the temperature of the substance and medium. And this is a differential equation. And we are going to solve this in terms of variable separable. We will get a general solution. Let's go. We have this rate equation available by variable separable. We can separate the variable is dt over t minus tm is equal to k dt. So we are going to integrate both sides of the equation, where left side will respect to the temperature while right side will respect to the time. So we will be having ln t minus tm equal to kt plus c. And now we are going to exponential both sides of the equation, and we will have t minus tm equal to e raised to the kt multiplied by e raised to the c. But again, e raised to the c simply equal to c. So we replace in term of c, we have now t minus tm equal to e raised to the kt multiplied by c. And we have now equation t minus tm is equal to ce raised to the kt. And we are going to have t is equal to ce raised to the kt plus tm. So we already have the solution of this equation, and we got the general solution. Back to the question, a metal bar with an initial temperature at 25 degrees Celsius is immersed in a container of boiling water. Obviously, our subject or our substance is a metal bar, has a reading of that degrees, and it is immersed in a container of boiling water, which is temperature of boiling water is 100 degrees Celsius, and 100 degrees Celsius is the temperature of medium. Back to the first sentence, a metal bar with an initial temperature at 25 degrees Celsius. So here we can see that temperature 1 equal to 25 degrees Celsius and time equal to 0. So we can proceed to the first condition, which is T0 equal to 25 degrees Celsius. Next, it was observed that the temperature of the metal bar increased 3 degrees Celsius in 1 minute. So we can proceed to the second condition, which is T1 equal to 28 degrees Celsius. The question is, determine the time required for the metal bar to reach 85 degrees Celsius. What is time when temperature is 85 degrees Celsius?
Where T is equal to 25 degrees Celsius, Tm equal to 100 degrees Celsius, and times equal to 0, we substitute into the general solution. And then we get the answer for C is equal to negative 75. Now we get the new particular equation, which is T equal to 100 minus 75 exponent to the power of kt. To get the constant K by condition T1 equal to 28 degrees Celsius, we substitute the T1, which is 28 degrees Celsius, into the particular solution, which is 28 equal to 100 minus 75 exponent to the power of K Next, we get 75 exponent to the power of k equal to 72. And then, we find the k with add ln into both sides of the equation. And we get k equal to ln 0.96 equal to negative 0.0408. The new particular solution we get is t equal to 100 minus 75 exponent to the power of negative 0.0408t. To get the answer for the question, which is when t equal to 85 degrees Celsius, what is the times? We substitute t equal to 85 degrees Celsius into the new particular solution like this. Next, we get exponent to the power of negative 0.0408t is equal to 0.2. We add ln into the both sides to eliminate exponent, and we get t equal to 39.43 minutes. Therefore, in 39.43 minutes, the temperature of the metal bar will increase into 85 degrees Celsius.
Question 2. A tank contains 300 liters of fluid in which 20 grams of salt is dissolved. Brine containing 1 gram of salt per liter is pumped into the tank at a rate of 5 liters per minute, and a well-mixed solution is pumped out at the same rate. Find the amounts A as a function of T of grams of salt in the tank at time T. 10 marks. To understand the question, let us separate the question into several sentences. First, a tank contains 300 liters of fluid in which 20 grams of salt is dissolved. So we have a big water tank in which we have 300 liters of fluid with 20 grams of salt dissolved in it. Next, brine containing 1 gram of salt per liter is pumped into the tank at a rate of 5 liters per minute. So we have solution input in which we have 1 gram of salt per liter at a rate of 5 liters per minute. Next, and the well-mixed solution is pumped out at the same rate. So we have the solution output, the well-mixed solution at the rate of 5 liters per minute. Lastly, find the amount AT of grams of salt in the tank at time T. So we need to figure out how much salt in the tank at time T. Planning. Solve this question by using normal linear equation in two variables because the variable amount of salt A is dependent on time T and also itself. So we have to solve this problem from the another approach, which is the differential equations. This question gives us the rate of input and output of the solution, which helps us to solve this problem using differential equations. Now let us start to solve the problem. First, amount of water is constant at 300 liters. We know that the tank initially have 300 liters of fluid in it, and the input rate and output rate is the same, so it makes no changes to the amount of water in the tank. We can count the flow-in rate of salt, dA in over dt, as a product of the concentration of the solution and the rate of input of the solution, which is 1 gram per 1 liter times 5 liter per minute, which yields 5 gram per minute. For the flow out rate of salt, dA out over dt, we can count it using the same formula. However, the concentration this time is not fixed. It is given by AT, which is the amount of salt in the tank over 300 liter amount of liquid in the tank. So this gives us the equation dA out over dt equals to AT over 300 liter times 5 liter per minute, which gives us AT over 60 minutes.
So we get the rate of change of amount of salt is equals to dA in over dt minus dA out over dt. So we substitute to dA over dt equals to 5 gram over 1 minus AT over 60. Ignoring the units, we will get dA over dt equals to 5 minus A over 60. Next, from the equation that we get, dA over dt equals to 5 minus A over 60 will be separated by first order differential equation They will give us dA over dt in a bracket 5 minus A over 60 times 1. So we separate the variable. We get 60 over 300 minus A dA equals to 1 dt.
So next we will integrate both sides, which means integrate 60 over 300 minus A dA equals to integrate 1 dt. So we get 300 minus A equals to exponential power of t over 60 times exponential c2 minus c1 over 60. So we're taking c equals to exponential c2 minus c1 over 60. So the equation is 300 minus A equals to c times exponential t over 60. So we arrange back. So at equal 300 minus c times exponential t over 60. So we substitute the initial value of A, 0 equals to 20. So 20 equals to 300 minus c times exponential 0 over 60. So we get c equals to 280. So when we get the value of c, we substitute c into the equation. So 80 equals to 300 minus 280 times exponential t over 60. So the answer for this question, amount of grams of salt in the tank at time t, at equals to 300 minus 250 exponential t over 60.